Hello. This will be a demonstration of Proposition 26 from Book 8 of Euclid's Elements, which says that similar plane numbers are to one another as two square numbers, that the ratio of two similar plane numbers is the same as a ratio of two square numbers. All we're given are two similar plane numbers, A and B. So A and B are both plane numbers and they are also similar to each other. What we want to prove then is that the ratio that A has to B is as the ratio of two square numbers. We begin by noting that because A and B are similar plane numbers, we were given that, we know from Proposition 8.18 that there is one mean proportional that falls between them, for they are similar plane numbers, and we know between similar plane numbers there is one mean proportional. We're going to next construct this mean proportional, call it C. So C will be the mean proportional between A and B, so that A is to C just as C is to B. Next, we're going to take the three numbers D, E, and F that form a continued proportion in least terms in the same ratio as A, C, and B. So D, E, and F are the least numbers that form a continued proportion in the same ratio of A, C, and B. And precisely because D, E, and F are the least numbers in that ratio in continued proportion, we made them in that way in the previous step by Proposition 8.2. We then know from the porism of that proposition, the porism of Proposition 8.2, that D and F are square numbers. Because D, E, and F, those are the least numbers in that ratio in continued proportion, and the porism of 8.2 tells us that the extremes of such a three-term proportion are squares, so D and F are square numbers. But we also know that the ratio that D has to F is the same as the ratio that A has to B. You would arrive at this by Proposition 7.14, which is the proposition about proportionality x equality. You would notice that A is to C just as D is to E, and C is to B just as E is to F. This is all given to us by virtue of the second step. And so we can go through the middle terms of C and B to compare the extremes directly x equality and say that A is to B just as D is to F. But D and F are square numbers. We had just proved that in the previous step. So that A and B are to each other as the two square numbers D and F. Their ratio is as one between two square numbers, which is precisely what we set out to prove, which means we're done with the proposition, therefore, etc., Q, E, D. What this would look like with particular numbers is we would know that the plane number 8 is similar to the plane number 18. We know this because we can represent 18 as a plane with sides 2 and 4, and we can represent 18 as a plane with sides 3 and 6, so that the sides between these two planes are proportional and that the two numbers 8 and 18 are therefore similar. What this proposition then tells us is that because 8 and 18 are similar plane numbers, they are to each other as two square numbers, that the ratio that 8 has to 18 is as one between two square numbers. And that's fairly easy to verify. 8 is to 18, just as 4 is to 9. And 4 and 9 are obviously both square numbers, so that 8 and 18, the ratio between 8 and 18, is the same as 1 between two square numbers, namely 4 and 9. That's all I've got to say about this proposition, so I'll end the video here and move on to Proposition 8.27.